Okie dokie, why don't we get started? Hi everyone, officially, again, thank you for joining me. And in this session, we're going to build a machine learning powered web application that I've called Nose Canvas. Some background about me, I am a generalist and I've worked as an AI engineer, a computer engineer, and a UI UX consultant, the whole gamut. I have also run a consumer devices company called Ring Theory since 2013. And right now I'm really keen on helping non-technical folk learn how to apply technology in creative applications. So that was me, and I really want to get to know you as well. Before we start this session proper, I want to get some idea on how much experience you all have with HTML, JS, and CSS. Here's a poll. I hope you can see it. You can go ahead and fill that in. I can show you the results as well, I think. About 90% complete, and it seems like most people are at the just a little stage, and knowing that there's also some people that are at the what's that stage, it's nice to have some intro sessions early on. So for those people who have lots of experience, we can also talk more at the end of the session or in future sessions when I go more in depth. And I have another question. The second question is, how much experience do you have with machine learning? Most people are in the beginner stages, and this session is really catered for you. I'll try to explain those concepts a little bit more in detail so that we can get up to speed on it. A little word of encouragement and something that speaks to me in this time. We all have the ability to create something beautiful that you are really keen for this class. But if you need to drop off at any point, just let me know, or just drop off and I will always be available for questions. Here's what we'll cover in this course. First, what is pose estimation and PoseNet? What is the basic structure of a web application, and how to create and launch a pose estimation web application. All right, does anyone have any questions so far? Good so far? Okay. What is pose estimation? This is where we estimate where the person's eyes, ears, nose, joints, and so on are in relation to each other. We're not trying to identify who is in the image, but rather where the human is in the image, if there is one. One example where pose estimation is being used today is in fitness games for the Kinect. You might know of this game. I personally have not played it, but it's detecting whether or not you're holding an accurate yoga stance. And here's a cool example that also uses pose estimation, and I'll show you some of it.
But tell me now, what were we thinking of? Everything that we had, well, it's gone to waste. If I stand in the sunshine, all I see is rain. So I tear my heart out.
Basically, what it's doing is it's mapping whatever pose it finds in a dancer and using it in combination with something called style transfer to make this lady here look like she's actually a fabulous dancer. And it's very impressive. I think later on she dances ballet and all kinds of things. So maybe we can just look at the ballet one for a bit. This is what they're actually doing. And this is what the machine or algorithm makes it look like they're doing. So really impressive things. And at this point, you might be wondering, how does the system actually detect a person's pose? And to answer that question, let's dive more into the machine learning pipeline. I can lead a more in-depth, pure machine learning session if people want, and go over more of the guts of machine learning, different models, and so on. But for now, here's the gist of it. So as always, machine learning requires a lot of data. And in this case, the PoseNet team used something called the COCO dataset. So if you go to cocodataset.org, you can find lots of images which are labeled. And the team used that to create a model that answers the question, how can we detect humans in a photo? In other words, like, what are the common characteristics that we can use to learn about what makes a group of pixels a person? Which, if you think about it from a computer's point of view, is really not that easy, because a pixel is just like a bunch of numbers. And once this model is strong enough, it can be used on new data, which is what we will be doing to make predictions on new photographs and videos. So that's pretty much it for the machine learning part. In this case, the team created 2 different models for detecting single bodies versus multiple bodies, with the latter being more complex and a little slower to execute. And when you feed an image into the PoseNet model, it will seek 17 pose key points, which is shown in this image, and that includes the eyes, the shoulders, the elbows, the hips and ankles, and so on. So if we start with an image that looks like this, we feed it to the PoseNet model, it will return us a list of information about the relative positions of different key points that the model has identified in the photo. And then using those key points, we can map out something like a skeleton of where the person is in the photo and use that for application. You might also notice that in the output, there's something called confidence, which just tells us how confident the model is that this prediction is what it says it is. How do we access PoseNet? So there are a number of ways to do that depending on your application. And this could range from diving headfirst into machine learning code or simply importing a library. And what is a library? It is a set of pre-written code nicely packaged into a single line of instruction. So we can do that with something called Google's Creatability project, which is something that allows us to access PoseNet with one line again. And it allows us to explore how creative tools like drawing, music, and more can be made more accessible using web technology. So they created some projects like this person using her face to play on the keyboard. And this person over here is also using PoseNet to play music. And I will go ahead and send the link for Creatability in the chat if you want to explore it further. This is the site which I just sent a link to. Before we dive into actually making the web page, I wanted to give you a primer on what is a web page. And at the core, web pages consist of 3 languages: HTML, JavaScript, and CSS. And like some of you have never seen these languages before, so don't worry. Think of these languages as commands that inform the computer of what it should present to you and how it should respond. So just like when you're learning a new foreign language, you really don't need to know every single word. And the good news is that unlike some foreign languages, programming languages tend to be very logical and readable for at least English speakers. So we begin with HTML, which defines the content and structure of a web page. This includes things like text, headers, and paragraphs. In order for the computer to understand it, HTML needs to be specified with keywords or tags so that the computer can behave as expected. To declare an HTML document, we start with tags that look like this. This is called open HTML tag, and this is a close HTML tag. So inside these tags, you might have open and close head tags, which contain information about the web page itself, such as the page's title. And you might notice that I actually indented the head tags inside the HTML tags, and that's just for readability. So you might also have body tags, and this is where you'll actually find website content. And because you might want to leave comments for yourself and others, which you want the computer to ignore, you'll find tags like this. And this tells the computer to ignore whatever is written inside here. Is that clear so far? Cool. So next we have JavaScript or JS. And this defines the behavior of a page. HTML was the skeleton, and this is kind of like the muscle, so it can move and interact. You might have guessed that this is where we are pulling the interaction from PoseNet. So today we'll be using a library called p5.js. Yes, it does look like a Titan. A library, again, is simply JavaScript code or muscles in this case. Maybe you can think of it like a helping hand. And P5 is a JavaScript library for creative coding with a focus on making coding more accessible and inclusive for artists, designers, and beginners. So as I mentioned, JavaScript is used to make web pages interactive. I'm going to give you a quick example. So let's say we want to use JavaScript instructions made using P5 to create this canvas with an animated line. And the axes you see here are P5's conventions for where the origin is, which will come into play later. So here is 0, and here's increasing X value and increasing Y value. This structure of P5 code primarily consists of two sets of instructions, which we create with the keywords function setup open close bracket and function draw open close bracket. And the actual instructions will be enclosed in this set of curly braces. So the setup block, as you can see with these comments, which are marked with 2 slashes, will only be run once. And the draw block or loop will describe instructions that will be run again and again while the program is active. So in this setup loop, we give the application instructions, such as in this case, create canvas 400 pixels by 400 pixels. And as you can see, each step of the instructions ends with a semicolon, which is kind of important for P5. And next, we want the system to have instructions which it will repeatedly carry out in the draw loop. So since we want the Y position to be increasing at each stage or frame, we can create a variable to encode this information. And we can name it anything we want, but for readability, I'm calling it YPOS for Y position. And the structure of this line looks a little bit like algebra, where we're saying, let YPOS be equivalent to 0 at the start of the program. So at the instance of each loop, which you can think of as frames in the movie, we want to start with a gray background, and that's what this line says. And then we want to add 1 to the Y position so that it can move downwards. And if the Y position is as much as the height of the canvas, so this is if YPOS is equivalent to the height, we want to reset it to 0, because otherwise it will keep moving further and further away from the origin into infinity. And at each point, we want to draw the line at YPOS, which spans from x equals 0 to x equal width. So there we go. That's a complete P5.js mini program. Again, does anyone have any questions here? Someone posted a link to the P5 editor, which is a great way to practice with P5. And I'll also go into where we can find P5 examples later. Now, the last form of information that browsers receive is in a form of style sheets or CSS. So we won't be touching on that today, but in essence, CSS formats web pages to make them look pretty. And you can find plenty of information about CSS and HTML and so on in the W3 Schools webpage, which I will share in the chat. So you can check that out in your own time. And in the meanwhile, we're going to jump right in to create a web app. We will be using a service called Glitch. And if you've never used Glitch before, it's a simple tool for creating web apps. It was created, I believe, in the year 2000. Its founders also created things like Trello and Stack Overflow, and I really enjoy how quick and easy it is to deploy product on the site for free. If this is your first web app, do not fear, we will walk through everything together. So the first thing you need to do is go ahead and go to glitch.com and sign in on the top right over here. So you want to click on New Project up here on the top right. And hello web page, your own basic web page ready for you to customize. Once you set up that web page, there are 3 documents here automatically set up for you with the extensions .html, .js, and .css. And the cool thing about Glitch is that you now already have a working web page. So if you go to show on the top bar, and you can choose to show in a new window or next to the code, but if I click new window, here is my very own website, and I have my own URL, which I can share with my friends or whoever, and it will be live. So you can also go back to Glitch and change the name of a URL over here on the top left. So I'm going to change that to like Creatability Live. You can change it to whatever you want or not at all. They're pretty cute names. I'm going to send a link to this page. And if you click on it, you can actually see me coding live, but you won't be able to see whatever I reference, which will be still in the Zoom share. Cool. There's the HTML tags, and then there's the header tags over here. So this whole thing is enclosed in an open head tag and a closed head tag. And inside the head tag, we can see things like open and closed title. And this title actually determines what is shown on the tabs when you see it like that. So right now it says hello. Inside the head tag, we also see these 2 lines. Well, it's 4 lines with 2 comments, but they're basically telling the browser where to go to look for the corresponding .css file and .js file. After the head tag, we see, let me make some space here so you can see that more clearly. We see the body tags, and inside the body, we'll find text. And this text is enclosed in H1 tags. If you're a designer, you'll know that that's meant to make the text bigger, which you see here. So hi there is an H1 text and some paragraph text, which is over here. So for this project, we won't be needing any of the placeholder body. And so we can go ahead and delete all of this. So since we deleted whatever was in the placeholder body, we are going to fill it in with the custom stuff that we need for this project. And we need to let the browser know that we are importing 2 libraries that I mentioned earlier. The first is the p5.js library, and the second is Google's Creatability library. And this comes in the form of script tags, which point to the files that other people have created. So I'm just going to paste it over here. This is what we have in the index file right now, what Andrea just posted. And what I posted is the sources of where these libraries are hosted. And I'll go over where you can find them later. But for now, let's just copy them and just understand what it's saying. So it's simply pointing to a URL where another person's JavaScript file is hosted. And if you open one of these links in a browser, you see that it's just a really long JavaScript program. That's all that it is. And having these 2 lines here gives us the ability to make use of whatever functions and variables that have been created inside these external libraries. So I don't see any questions. You might be asking, so now we have the libraries in there, but how do we actually make use of them? So for the P5 library, we can go to p5.js's example page. Let me find the link and send it in. Here you go.
Sorry, I'm sorry.
It's okay.
I apologize to all of you who are like sitting here going, can't this woman cut and paste something? How many PhDs does it take? But it's just that everything has disappeared now on my glitch screen. Does it matter if it's fully formatted? I mean, as long as I know now that that's what's gonna look funny?
Well, it doesn't really matter, but it will help with readability.
Okay, no, I got it. I've got it. Okay.
Yay.
I'm in.
Okay. Awesome. Right now, again, just to reiterate, we have a very basic boilerplate HTML page, and we have deleted whatever was inside the body and replaced it with 2 script sources that point to 2 URLs where somebody else has written some JavaScript code. In order to use the P5 functionality, we want to refer to some examples, and the good news is that P5 did an amazing job with documenting examples, and you can find a whole host of motion graphics available on the web page. For instance, if I want to find something that draws a continuous line, I can just click over here, and this is working code that allows me to draw continuous lines. Amazing. For the Creatability library, which is the first URL over here, we can find a reference on Google's GitHub page, which is over here, and I'll just share this link into the chat. So this is what I would normally do when referring to some documentation, just so that I can copy and paste things easier. So again, I'm going to reiterate our goal. Our goal is to use the Creatability PostNet library to identify our nose from a web camera and to use that to draw a line on the screen. If we refer to this page, it gives us a library with an element called ACC Post Input, which we can put into our HTML page. And if you click on it, we'll see HTML code that we can simply copy and find my HTML page and paste it inside body. So what I did was I took a line of code from this documentation and I put it just after the open body tag. And you can read more about all of the different descriptions of this tag over here, like amplification, smoothing, and part. But I'll just explain to you what amplification is how far away from your nose it's going to be detecting. Because for accessibility, maybe some people aren't able to reach the whole screen with their posture. So they need something that's further away from where the nose actually is. I don't need that for this example, and so I'm just going to delete that. Smoothing, that's fine, 0.5. It just means that there's some processing that will be applied to whatever results are being returned. And part says nose. If I go back to this library, I can just search for nose, and I can see that instead of nose, there's other things that I can use. I can use left eye, left ear, right ear. So anything that I find over here, I can replace in part, and then my program is going to recognize that part instead. But for now, I'm just going to use nose. So now I have this line from the Creatability library inside my HTML page. And what happens if I open this page? Nothing. And that's because we have only given the web page a skeleton, but we haven't given it muscles. And to give it muscles, we need to give it information in the JavaScript page. Okay, I'm going to stop here since there's some questions. So amplification is how far away the detection is from your actual body part. So you see how there's a line connecting this dot and this dot? If amplification is 0, then both dots will be overlapping each other on the nose. But in this case, there is some amplification, and that dot goes further away, which allows this person to access areas of the screen which are further away from where her nose actually is. Where were we? We were saying that there's nothing on this page because we haven't given it muscles yet. We've only given the structure, the skeleton. So we want to go to the JavaScript file. And because we're using P5, we can just simply type the two functions that we always use for P5, which is function setup, open close bracket, and function draw, open close bracket. And you can just copy this from my code again. I think it's more important to read it and understand what it means, and also where in general you can look for answers to your questions, because that will allow you to build much faster instead of getting bogged down by like actually learning the entirety of the language. Okay, so the first thing we need to do, which is the case for most P5 applications, and it's also something that we have seen in the P5 examples, is to create a canvas. So this line says, let canvas be equivalent to something called create canvas that is the size of the width of the window and the height of the window. And then this semicolon here, important. Now we need to set up a connection between the JavaScript and the ACC post input block, the HTML block, which we have pasted in our HTML code. So to do that, we can refer to the JavaScript instructions on this GitHub page. We see here, const input, let me just copy it, equal document query selector ACC post input. And what that means is we have set input be equal to the ACC post input block that we have just pasted in the HTML page. So every time we refer to input, we're referring to this thing.
Sorry to interrupt. Is input a variable?
Yes.
Okay.
So again, if you've done algebra, a variable is just a name to refer to something else. Like x equal 2 plus 3.
Right, it's a variable, not a actual function or command, right?
No.
All right, thank you.
And then what we need to do, which also is in this documentation, is to initialize the input. And that's simply something that was created in the Creatability library that allows us to use the PostNet functionality. So remember to end all of your lines with semicolons. And then the next thing we need to do is to map P5's position to the HTML coordinate space. So P5 is a JavaScript thing, and HTML has its own coordinates, and we want them to gel together. So we can see in the documentation that there's this thing, input.content element equals HTML element, and we can use that over here, input.content element equal HTML element. However, P5's HTML element is called canvas.elt. So now you can copy this line into the setup block. So if we go back to our page again, it's asking for a camera. We still don't see anything, and that's because we have only set it up, but there's nothing being drawn in the draw loop. Before we actually start on making things in the draw loop, we already know that we want to reuse variables that are declared in the setup loop. And something about the way that I've done it is that these variables are currently only available inside these curly braces. So in order for me to use them inside the draw loop, I actually need to take them out and declare them at the start of the program, which is like how I did the Y post earlier, if you remember. And I'll do that like this. And delete these declarations of let canvas and const input from here. I'm declaring them at the start of the program, and in that way, these variables are available to both the setup loop and the draw loop. So Krisanti asked, what does input.content element equal canvas.elt mean? And that's just mapping the coordinate space of P5 to the coordinate space of the input. Cool. So we are mapping P5's coordinate space, which is called element, with the HTML coordinate space, which we have found in the documentation. Awesome. The next thing we want to do is to set up the canvas to display the video feed. And this video, because it's going to be drawn again and again, we want to do that in the draw loop. So this is the line that you use to draw video. You can just copy and paste this. This is available in any reference example. Is anyone able to see their own faces on their page?
Yes, I am.
All right, so you should see your face, but it's not doing anything. And that's because we haven't connected PostNet with whatever is being shown in P5's camera. So just want to give people time to catch up if you've not already reached this place. Oh yeah, maybe I should turn off my Zoom camera. It is lagging. So just copy this lines and copy this line, and then you should have the video working, but nothing beyond it. What we need to do now is to get PostNet to connect with P5, and we want P5 to just display a simple shape. To find an example for simple shapes, again, we go back to P5's example library, examples over here, and we can look for something called simple shapes. Here, hello P5 simple shapes. And we can see that this is how P5 allows us to make shapes. You just declare a fill, which is the color, and the stroke, which is the color around it, the color. And then you can declare what kind of shape you want. In this case, I'm going to choose the ellipse shape. I am going to make a fill and stroke and declare an ellipse at the position of the input's X position and the input's Y position. So because this moves at every frame, I'm going to get, hopefully, a circle that moves along with my nose at each frame of the draw loop. All right, are we ready to see if it works? Cool. So my face is a little stretched, and that's because the camera is the full width of the page. But if I make the page a little smaller, then you'll see that it works. So we just created a machine learning powered pose estimation web application. If you followed along, you should have this right now. Works. Yay! Good job, Erin, Lucy. Awesome. Okay. So we've come really far. You now have a working website with a dedicated URL that you can actually share with your friends. So if you go again to the URL, you can copy this thing, you can share it like in WhatsApp and Slack and just show people that they can go to your site and play with this dot in their nose. I want to go ahead and make this a little nicer. I don't think I'll go into each step of the code right now just because I want to give time for another part of this activity, but I'm happy to walk through it after. So what I did was I basically created a holder to take note of where each point is and update it at every step of the loop. And if I show this code, hopefully you'll see something nicer. There we go. So now I can draw. So this one draws just a black line, and you can go ahead and change the colors. To make it purple, you want to go to stroke and decide on another color. So you would change the color here.
Sorry, can you show me that again? Where I would go for stroke?
You would go to script.js and look for stroke. You can change the color here. They're usually numbers for if you want very specific colors. P5 has created some easy ways to reference nice colors. So for instance, if I do yellow, I can do show, and now the line is yellow. They might have purple too. Let me see. Yeah, that's a dark purple. Did that work?
Where is the amplification again in the code?
Index.html. Under ACC post input, you might see amplification equal 3 or something. You can remove the whole part that is talking about amplification.
Perfect.
Oh yeah, so there's another thing in my code. I added something called mouse pressed. And somebody's talking about how when you click on the page, it resets. And that is a feature that Google Creatability activated so that for people with issues with body movement, they can quickly reset the pointer to wherever their body part is at that moment. So if you run my code as it is, and you go like far away and then you click on the page, you'll see that shift. How to reset and erase a line and draw new drawings again. So for now, you can refresh the page to reset. If you want to do something like a button, you would need to create that in P5. And we can go over all the different techniques. And I just wanted to give you like a very broad overview, get everybody able to run something that works. Happy to discuss how to go deeper. Will this work on a smartphone or iPad? I think so. All of the code that we're running here will work on any tool that allows you to open a browser.
I also just found out that if you have an ad blocker or a pop-up blocker on, it doesn't work.
Oh, that might be because it's popping up to ask for camera access. So you do need to grant the browser camera access. And a point on that, while we're here, a note on privacy. Your images are not actually being sent to Google servers while you're using this webcam tracking tool. In fact, all the image recognition is happening locally in the browser. You can look this up on the documentation as well. And I think that's something that's really important as we create such applications as designers and artists. Okay, so you now have your very own machine learning powered post tracking application. Congratulations, and thank you so much for not giving up on me, all 50 of you. While tech can seem very daunting, I'm so excited that with these tools that are available, we can break down the concepts so that you can use them effectively in your work. This is another quote that I found very impactful. It says, "You don't make progress by standing on the sidelines, you make progress by implementing ideas." Does anyone have any questions? Or would you like to see more projects? If so, you can let me know in the chat. Otherwise, because this group is pretty large and I really want to give everyone some time to get to know each other, I came up with an activity that we can do. You don't have to if you don't want to, but here's what it is. So I thought I would create breakout rooms for everyone, and you can introduce yourselves, and maybe since there's 50 of us, we can do like 10 different rooms, and you can share something about your day. I can float around from room to room. You can share your screen and work on projects or get your questions answered. Another thing is that the breakout rooms will not be recorded, so you can talk about anything that you don't mind Zoom hearing. And finally, I'm going to create a channel on Slack called CAT. This will be something that allows us to post ideas and questions and completed projects. This stands for Creative Applications of Technology. it's an idea that I had, especially for people with less technical backgrounds, to learn shortcuts, overviews, and skills and quickly prototype creative ideas. I hope to extend this CAT series with more classes, and it's really experimental. So will it work? We will see. Lastly, I have a survey for anybody who has stayed till now. If you want to go over to bit.ly/catproject1, I will also share that in here. And you can really help me to figure out what worked, what didn't work, and how I can do better. I'm really excited to make more of such classes. So any feedback will really help. Okie dokie.
This was probably the most happy time of my life.
Thank you so much. I really appreciate that.